we're going to talk about adding and subtracting rational expressions. Okay? Now remember, rational expressions are really just polynomial fractions. So let's talk about how to add and subtract fractions first. Okay? If I have 1/8 plus 3/8, then I can do that pretty easily enough. The common denominator tells me all I have to do is add the numerators, 4/8. And I'm really done with the adding at that point. After that, I can do a little simplifying, which I can divide a 4, in this case, out of both. And so I get 1/2. Okay? But this is really 2 steps. The first step is to add, and after that, I'm just simplifying. So to add, really, I just add the numerators. This is no different if I start to throw variables in. If I have 7x over 9 plus y over 9, again, I just need to add the numerators. Well, they're not like terms in this case. So 7x plus y is their sum, again, over the common denominator, just like up here. Okay. If I did have like terms, say I had 7x over 9 plus, well, let's not use 3. Let's say just x over 9. Then I can combine these when I add them. 7x plus x is 8x. So whether I can combine them or not just depends if they're like terms. But in essence, it's the same as this fraction. All I've done is add the numerators over the same denominator. Well, again, if we've got a variable in the denominator, still not going to be any different. Okay? 8 over 3x squared plus 14 over 3x squared. I've still got the same denominator, so all I have to do is add those numerators. And I get 22 over 3x squared. What if I want to subtract instead of adding? Well, really the same idea, except instead of adding numerators, I subtract numerators. 1 minus 3 is -2. Okay? And I can divide a 2 out in this case. There's a 2 in common there. So -1/4 would be my answer. Okay, so it's just the same idea, except now I'm subtracting the numerators. For example, this would be 7x minus y over 9. This would be 7x minus x, or 6x over 9. And I can reduce that a little bit. There's a 3 in common. So I would get 2x over 3. And here, 8 minus 14 is a -6. And again, I can reduce because there's a 3 in common. So I have -2 over x squared. Here's another one that's going to take just a little more work, but it's the same basic idea. Okay? We want to subtract these. Notice the denominators, even though it's a little more complicated than the previous examples, still the denominators are the same. So that means we can just subtract the numerators. Okay? Well, you have to remember that when you're subtracting polynomials, When I subtract this, I'm subtracting the x and I'm subtracting the negative 1. Well, to subtract a negative 1 is the same as adding 1. So I end up with 2x minus x is x, and 5 minus a negative 1 is a positive 6. Okay? Now, the subtracting's done. From here, I might be able to simplify. And remember, to simplify, I need to divide out any common factors like I was doing in the previous examples. What you don't want to do, remember, is you don't want to say, well, there's a 6 and an 18 here, I can just cancel there. Because the 6 is not a factor. It's being added to the x, so it's a term. Same thing with this negative 18. Not a multiplication going on here. So I can't divide those out. I need multiplication to divide it out. So instead what I need to do is factor. X plus 6 I can't factor. It's already prime. X squared plus 3x minus 18 I can factor as x plus 6 times x minus 3. And that shows me that I have x plus 6 in common, so I can divide that out. And I end up with x plus 6 divided by x plus 6 is just going to be 1 over, that'll cancel that out. I just have an x minus 3 there.